Hello, my name is Tom Rummage with the Applications Engineering Department here at Micro Measurements. Today we're going to be bonding of a 235 SL C4A strain gauge, 350 ohms, available on our online shop. We're going to be using the M-Bond 200, the cyanoacrylate adhesive instant setting, typical of a lot of stress analysis applications. I'm going to begin the process, and I will also be bonding to this cane. A large number of our customers are now going to prosthetics that have feedback devices, some of them in the ankle, some in the foot, some in the knee. This is just a cane and therefore probably would never be used for a prosthetic device, but it demonstrates the concept. I'm going to bond that gauge into this positive radius right here, demonstrating that the gauge can conform to an irregular surface. It has pre-attached lead wires, so I won't have to solder. If you're not into soldering, then that's the C4A series of strain gauges for you. We're going to be using a 3-wire configuration. This particular gauge comes in both 2 and 3-wire configurations, nominally 3 feet or 9 feet of lead wire pre-attached. So at this point, we're going to move on to our bonding process. Okay, to begin with, we're going to degrease the surface of the part using our CSM3. I'll take that and put it into a gauze sponge, our GSP1, saturating the gauze sponge, and then degreasing the area of interest, in this case on the radius of this cane. Once I've done the degreasing operation, removing any oils from my hands or any contaminants that might have been on the surface, the next step will be to dry abrade with the 320 grit silicon carbide abrasive paper, the SCP-2. I'm going to lightly abrade. It's taking off the paint, or in this case it might be anodization, and since it's a colored anodization, we definitely want to get rid of it. Alright, once I've completed the dry braid, I'll take a little bit more of the CSM3 and get rid of the particulate matter. I'm now going to continue the surface preparation. I'm going to use the conditioner A, the mild phosphoric acid solution, and I'm going to use that in conjunction with the SCP-2, the 320 grit silicon carbide abrasive paper, and I'm going to wet abrade the area of interest. In this case, since it's a curved surface, it's probably going to, a lot of it's going to run off, so I'm going to wet the silicon the silicon carbide paper and the surface. I'm going to hit that a second time. It has a little bit more surface than I'd like to have there as far as paint left behind and that sort of thing. So again, wet abrade with the conditioner A. This is getting rid of the organic and or surface corrosion that might be occurring on the part, helping us to make an intimate bond. I'm going to take a gauze sponge, GSP1, and with a single wiping motion absorb the contaminated material off my gauge site. Next step is we will go to the 400 grit, the SCP-3 silicon carbide abrasive paper. I'm again going to use the conditioner A and wet abrade with the conditioner A and the 400 grit silicon carbide abrasive paper. This is going to give us the surface finish. You don't want it too smooth because there's nothing for the adhesive to bite onto, and you don't want it to be too rough because that'd make it difficult for the gauge to conform. So we're going to get to a surface finish of nominally about 60 RMS. Again, removing the contaminated material. Alright, now we've got the surface to the surface finish we want. We've removed the gross contamination and oxidization. We're now again going to use the conditioner A, the mild phosphoric acid solution, and we're going to scrub the surface with the conditioner A. Note that my finger is close to the back of the cotton tip applicator, the CSP1. And I'm going to clean that up until I come up with a relatively clean cotton tip applicator. I'm going to switch to another one here as that one became soiled. And I'm pretty comfortable with that surface cleanliness. Again, between each one of these steps, we take a clean, dry gauze sponge, fold it into quarters, and we absorb the material. You don't want to let it dry on the surface. If it dries on the surface, it becomes a contaminant. The last step in our surface preparation will be the Neutralizer 5A. This brings the pH of the surface back to either neutral or slightly basic. It's the blue tip bottle. I'm going to again take a cotton tip applicator, flood the surface with the Neutralizer 5A, and I'm going to scrub it. The cyanoacrylate, if the last step we had used was the conditioner A, I can almost guarantee a lack of success because of the acidic nature of the surface. M-Bond 200 or the cyanoacrylates in general do not like an acidic surface. So now I've got it to the point where I'm ready to bond the strain gauge. I'm going to set my prosthetic device slightly out of the way here. Get a nice clean surface to work from. Now I want to lay out the gauge on this glass plate and then transfer it to the part. And in this particular case, because it has a lead wire attached and I'm on a compound curvature here, I'm going to run the gauge tape transverse to the long axis of the gauge. First thing I got to do is remove it from the packaging. This is anti-static packaging. You don't want to have static electricity. Then I'm going to remove the twist tie that holds the wire together. Now remembering, at this point this gauge is fairly fragile. It's fairly easily damaged in an unbonded condition, so we've got to be real careful with it. So I'm taking the lead wire, getting a little bit of it out here, leaving it in the acetate folder for a few seconds. The next step, because we are fastidious and we need to keep things very clean, I'm going to put a few drops of Neutralizer 5A onto the glass plate. Now you ask yourself, why am I using a glass plate? Well, it's real easy to clean, and it's also real easy to identify if it's dirty. If it's grossly contaminated, take a straight edge razor blade and scrape away the excess, and then take the Neutralizer 5A and scrub the surface. Having finished that, I'm going to lightly dry it. I'm now going to use the PCT 3M gauge handling tape. It's a mylar tape with a silicon mastic. I'm going to pull off the first piece, about 2 to 4 inches long, and I'm going to throw it away. You never know where that tape's been. You don't want it to be contaminated. I'm now going to pull off about a 4 or 5 inch piece here. It's not critical. And cut that off. And I'm going to set this on the edge of the table in preparation for the gauge. I'm going to slide the gauge out of the acetate folder. I'm going to lay it down on the glass plate. Then I'm going to take the tape and I'm going to run it transverse to the long axis of the gauge. Now, it's not critical that the tape be exactly 90 degrees to the surface, but it tends to help if you can better align it. I now need to transfer from the gauge handling glass plate over to the part. So I need to get my part here. Lifting at a shallow angle. You don't want to bend the gauge as you're lifting it up, the tape off the glass plate. I'm now going to align it on the surface of my part in the direction that I'm interested in measuring. And I'll lay that out. Note, if I ran the tape this direction, it would put the tape into compound curvature and would likely cause some damage to the gauge. So I'm running it radially around the gauge. So I want to make sure that the gauge handling tape is well adhered. I'm going to lift up at a shallow angle again, don't want to damage the gauge. Expose the bonding surface of the strain gauge. Now I'm going to begin the process of putting the adhesive down. First thing is we need to use the Catalyst C, the blue bottle that comes with the M-Bond 200. The Catalyst C, to call it a catalyst is really kind of a misnomer. It's more of a controlling agent. On the inside of the neck of the bottle, I'm going to hit the brush 8 to 10 times. I'm going to take away most of the material, leaving very little behind. And then with a single wiping motion, I'm going to wet the backing of the gauge. I now wait 1 full 60-second minute. We've now completed our 1 minute of air dry time for the Catalyst C. I'm going to take the M-Bond 200 and I'll have a gauze sponge at the ready. I'm going to put a single drop of the M-Bond 200 at the cusp of the tape and the part. I'm then going to wrap it around and then clamp it up with my thumb. Now you ask yourself, what is the proper thumb pressure? Half a white thumbnail. I'm only kidding. Hold this. Now with the gauze sponge gone, we hold it for 1 full 60-second minute. Be sure and trust your watch, not your head. Your head's in a hurry. Pressure with my thumb. Now, likely as not, you might get yourself stuck to your part. Guess what? I'm stuck to my part. Now, I could just lift my thumb, but that would take off a chunk of skin. Well, the appropriate action is to rotate. Get it to shear away. And now I'm going to leave this under the tape for another 2 minutes. Okay, my next step before I remove the gauge handling tape, because this lead wire is already attached, I want to strain relieve it so it doesn't have a problem with the gauge. I'm going to take some of the paper drafting tape, PDT3, 1 inch or so of it, it's not critical. And a little ways down from the gauge, I'm going to tape down the lead wire. This keeps the lead wire from flopping and doing damage to the bond line. Now, how do I remove the gauge handling tape? First, I have to find a way to get it open. The edges of the tape stuck together. Rookie mistake. All right, now, how do I remove the gauge handling tape? I'm going to take it and pull it 180 degrees back on itself. That puts the adhesive into shear, where it's strongest. And I'm going to take the gauge handling tape, peel it back, exposing the gauge, and voila. Okay, I've completed my bonding of the 235 SL C4A strain gauge. It's a 3-conductor, a 9-foot-long lead wire system gauge. It's a common gauge on our MM Shopping, or MM Shop, the online shop that we've set up. I used the M-Bond 200, the cyanoacrylate adhesive system, and I'm going to apply an M-Code A environmental protection here in just a second. Once I've let this sit for just a little bit, I want to make sure the adhesive has a chance to fully cure. The final step of the application of the strain gauge, in almost all cases, would be to add an environmental protection. And since this is going to be under laboratory conditions, I'm going to use our M-Code A, a polyurethane material, air drying. I'm going to open the cap, and just like any other painting, I'm going to paint a layer of the M-Code A, the polyurethane material, covering the gauge. And for laboratory conditions, this is basically to keep the errant dust and debris and that sort of thing out of the strain gauge, which could have a long-term effect on its stability. As a compilation of what we have already done here, we bonded using M-Bond 200, a 235 SL strain gauge, uniaxial strain gauge, C4A series. It's an Advanced Sensor Technology resistance adjustment. We used the M-Code A as an environmental protection, good for laboratory conditions. And now we're set to take our data, either statically or dynamically, depending upon what the application would occur. And so at this point, we'll just wait for the M-Code A to cure, and away we go.